Okay, let's get started while we do the last mic. So this will work really well because what we'll do is we're going to talk about sort of like the frontier next steps of what happens in DePin, but also I think given who we have assembled here, there's an interesting story about sort of like the operating system of DePin, the stacks, so like how these things fit together. Kind of continuing the collaboration meme we were on a minute ago. So if you don't mind, just sort of one at a time this direction, can you just introduce yourself and what your project is, and then sort of how you fit into the DePin universe?
Molly Mackinlay. I work on Filecoin, one of the earliest, largest DePin networks out there, and also aiming to be a storage layer that supports many awesome DePins, powering some of the awesome work that Tableland Basin is doing, and generally also involved in Filecoin core protocol development.
Hey everyone, my name is Larry, head of business development at IoTeX. We got started back in 2018 building infrastructure for DePin. There's a lot of different layers that are needed. Things that we focus on are how to give decentralized identities to devices, grabbing the data from those devices, computing over that data, settling these proofs onto layer one. So cover a lot of different layers, but we started as a layer one blockchain and adding a lot of middleware and tooling that's DePin specific to that stack.
Hello, hey everyone. My name is Evgeny. I'm co-founder of Fluence, where we're building decentralized compute network, which we call cloudless compute network. We like this term. We invented it recently. We basically we are building alternative to big cloud computing providers like Amazon, Google, and Azure. And we are announced mainnet 2 days ago, and actually coming live in a couple of weeks. So we're excited about this moment.
Hey, my name is Vuk. I'm the founder of Web3Mine. We are aggregating a bunch of compute networks, and we think that it's going to be thousands of networks, so we are trying to help every new project bootstrap by building a bunch of tooling on top.
Cool. So we sort of have, this is going to be wrong, so you can, it's good if people disagree with each other, and you can start by disagreeing with me. We sort of have like Vuk, I know you do more than this, but I can kind of think of you as like the collection of machines in a way, right?
Yeah.
And we have storage, and then we have compute, and the sort of like general purpose compute. And then IoTeX, you pretty much specialize in like this verified data connection out to the outside world, right? Is that a good way to think about it? Is it like, is this one slice of the DePin operating system? Am I making that up?
Kinda, yeah.
Kind of making it up, or kind of it is true?
Ultimately, at least the way I reason about it, it's mainly around the economies. So what we're trying to do is just connect the different layers. So on one side, yeah, we have the machines, but for us to be able to capture value from these machines, we need to participate in these economies. So we have the second layer, which is sitting on Ethereum, where we allow these networks to have exposure towards these networks. Like on Ethereum, we have liquidity there and a bunch of other stuff, so that we can actually have an active participation in these networks. So sure, yeah, the machines are there, but we would never sell machines. What we're doing is liquid staking by actually having these resources available for us. And we try to do that for a bunch of networks. We believe that all these networks will need to be on Ethereum, because this is where most of the economies are, and this is where most of the value is. And yeah, we try to help them out, just get more value.
Yeah, I think the analogy with the Filecoin Fluence side, at the very least, is reasonable, where there's storage network with, I think we've now passed 2 exabytes of storage stored in Filecoin, which kind of blows my mind. And that combined with decentralized compute networks and being able to, we just had a great conversation yesterday talking about where you have a Filecoin storage provider with a large scale storage repository. You have your compute node sitting on the same data center, same hardware. You're running your compute jobs over your data stored in Filecoin. You're putting the output, which might be large, might be small, back without having to do egress from that cluster. And then you're making that available to your compute job client or runner. And that kind of is tying together the storage and compute sides of these different DePin networks. And it sounds interesting with the IoTeX stuff of then maybe exporting that, or you can even orchestrate entire DePin networks that are using those building blocks to then power other networks as well.
Yeah, I think if to use your slice analogy, right? There's a lot of slices in blockchain naturally, like popularized by a lot of these modular protocols like Celestia, right? Data availability layer, execution layer, consensus layer. But once you start to talk about DePin, you extend out the slices into the real world. Then you have to think about the hardware layer, the firmware layer, the identity layer, connectivity layer, long-term storage layer, different, a lot of different layers that need to be thought about that aren't just things that a DeFi project would need to think about, right? So, I mean, we started to draft up this kind of like DePin report where we defined 9 different layers, some of which are covered by IoTeX or Filecoin or Fluence or et cetera, right? Like, there's so many different components that a DePin project needs to work at like a best practices level. But some of the things that were said in the previous panel, like you don't need to decentralize every single layer first, but over time, as infrastructure providers work on decentralizing those components, fitting those decentralized layers into your stack over time at the right time, I think is what DePin projects should think about.
Yeah, one comment on slicing actually, because we are doing compute, and compute is a very big kind of actually area, right? Or the very big market. For example, if you look at Amazon, they have like hundreds of services, and it's all compute, right? It's basically about slicing the patterns of using compute to different services. So when we actually talk about compute DePin projects, it could be like many of different projects doing like specializing on very different tasks. Like we are trying to do more, cloud functions stuff like Lambda, but actually there are like many other kind of areas here if you think of kind of understanding the whole compute market.
You mentioned, is this off? It is. I guess the battery wasn't okay on that one. You mentioned functions in Lambda, and like compute is such a general thing. We had a panel earlier where we were talking to like GPU providers and Akash, which is not just GPU, it's just like you can rent a server, And there's this like gradient of doing very special purpose compute versus general compute. And I guess the same is probably true for pretty much everything that all of you are doing, like general purpose versus specialized. You end up with then sort of like probably worse UX or developer experience the more general you are, but of course a more open sort of environment and the ability to do optimizations and better developer experience the more specific it is. Like, do you have a point of view, any of you on that, of like the more general versus the more specific? In like filling out this operating system metaphor.
Yeah, I may just continue a little bit. So I think like the biggest adoption challenge for Web3 networks and DePin networks is to build the proper product, build a proper end-to-end scenario. So like we can easily onboard users from Web2, like seamless migration from Web2. So I'm using Amazon and I just go to this DePin network, do a couple of clicks, and I migrate my workload there immediately. That would be awesome and perfect, but actually almost none Web3 projects work this way right now. And this is mostly about specialization. So I think specialization is more important right now for DePin networks than being very general purpose. Because general purpose is like, yeah, we can create this network, you can use it, but to use it you have to do like 10 steps and we lost you, like we lost customer, or like it's also like it's on a technical level, on payment level, on legal level, like its challenges are everywhere. So I think we should first of all think about like vertical end-to-end use cases, make them work one by one, and then we're gonna be able to migrate people from Web2.
Yeah, the thing I was going to reference, there's a kind of compute over data working group in kind of the ecosystem that has been working on some standards like Bacalhau that are used by a number of different compute networks, which is Portuguese for COD, compute over data, which is how that joke makes sense. Otherwise, people are like, why is it called this weird fish? That's very silly. Anyways, so that community is kind of broken down 3 different kind of subclasses of compute networks that are optimizing for like highly performant, efficient compute, highly kind of like privacy-oriented compute, like what Zama's doing with fully homomorphic encryption, and then highly verifiable compute that's like ZK all the way through, things like what Lurk is doing with like ZK, kind kind of like languages for kind of like proving compute jobs. And Juan actually put it together and described it as Juan's triangle. Awesome. It exists where you can have different networks that are optimizing for different things. And I think that's great. And I would really like to see orchestration between some of those different compute networks, because I see an opportunity to have kind of like hybrid jobs that will actually move from network to network. So if folks are interested in that, I'd like to figure out how we can get some of that at like maybe the Bacalhau level, or it's something that's like a standard or interface level where you could have, you know, jobs that flow from like super efficient, optimized, optimistic compute network level to like, great, we're gonna spawn a fully homomorphic encryption job that is very private and very, you know, happening in a fully encrypted way or over fully encrypted data. And then you can come back and keep executing in your maybe more efficient compute network. So I think the interop between different compute networks is going to be really interesting as well.
Yeah, by the way, for this composition, we would love to use our cloudless functions in Aqua because it's created to like compose different compute workloads together. So would love to pitch it to everyone.
Yes, so our view is that since we are going to have tens of thousands of different compute networks, ultimately we are gravitating more towards that each framework is probably going to be a compute network, and we need to figure out how to actually enable these developers to build their own stack on how the execution of the workload should be. So for example, that could be TensorFlow, and in the context of the cloud, what already has happened is that Kubernetes had a managed Kubernetes, but it took tens of thousands of engineering hours to actually get there. But in the context of a decentralized framework, you can have a bunch of contributors in your ecosystem that are basically building all the different pieces in order to execute these workloads. So for us, it was really reasoning about what is that unit of compute that needs to be executed, and ultimately the only thing that we could just abstract on the top was input of a job and the output of the job. So like we are not even getting in the execution because ultimately the execution needs to keep being optimized by each of these jobs or communities or by the providers. Maybe the provider wants to invest in a FPGA or has a ASIC farm that does a subset of the job, and we should allow providers to be better at whatever they are doing. So ultimately over 20 years, we should probably get to over-optimize execution paths for each of these jobs if we do a relatively good job doing that.
Yeah, I think like from my perspective on this topic of specificity versus like generalization, I think like DePin has grown a lot in the past couple years because the supply side of the equation is kind of being solved, right? We started with Helium manufacturing their own devices, and that was a huge hardware barrier to entry. Now we have a lot of bring your own device, third-party device networks where you have these kind of general purpose devices that honestly can provide services to multiple protocols at the same time eventually, right? I think that's honestly my holy grail for DePin is single device, multi-protocol, multi-token miner. And I think that like generalization of the hardware is going to help a lot. But yeah, I think for data itself, let's not talk about compute for a second, but like the data that's coming from more sensor-based DePin networks, I think it's really going to be interesting to add that like data science layer component, and that's really like the specialization, right? What insights are you extracting from the same data is going to be really like the differentiation of the demand side for a lot of these projects. Maybe we're all pulling the same weather, humidity, air quality data from this device, but the way that it's used, whether it's for insurance or for, Yev was talking about all these different use cases that are going to be built on top of this general purpose data pool that Demo is collecting. I think that's going to really differentiate projects in the future. Specificity of the use case of the data or the compute or the resources.
Yeah, it's interesting how pretty much all of you referenced somehow standardization. And I guess that's part of the continuum is like the more specific things are, the more you have to work together to create a standard, which pushes things either toward silos, which I would argue in Web3 has been happening to a horrifying degree, or very general kind of unusable, or at least layers that need to be built upon. Is this something that decentralization is good at? Like, it's funny. I made this analogy at the beginning, and we all started talking about operating systems. But imagine if we all got together and said, let's have like 100,000 people create an operating system together. How would the layers interact? How do we solve this sort of problem and get more interop happening?
Yeah, I think the question is decentralization on what level? We used to think about the tech, but actually the communities are very centralized. So if you look at the Solana community, it's very separate from the Ethereum community. And like even often they try to like have separate events in different times just not to kind of mix those communities. And in the beginning, it was even like kind of trying to compete with Ethereum. So like maybe trying to capture some of the developer adoption that Ethereum had. So the communities are very isolated, and like usually what happens is that wherever whatever happens on a human level, usually you get that on the software side. So that's kind of why we got like that crypto moment where like everything is kind of separate. There is one big community right now, which is the EVM community in the context of development and everything else. Now the issue is that we thought about networks and that things should be on networks. So like no one thought Ethereum should talk like a language. Everyone thought it should be on Ethereum. Is it on Ethereum? Is it on Solana? That's not the right question. Like the right question is how do we actually pass information around and how do we actually talk the same language, which in the context of DePin is like super important because like the communication probably needs to happen completely off chain because that computation is happening on a physical machine. That physical machine is not connected to any network. It does not have enough time to have consensus with whatever else because that job needs to be executed on a millisecond level. So defining these standards is going to be super important. And Protocol Labs did like a great job thinking about this like very early on, 2015 for IPFS. And I think it's a great place to start and think about these standards.
Yeah, I guess similar to I think both of you guys said was around like you need modules, and then you're actually going to have the same nodes and a lot of overlap where a node is running many modules that need some common ways of like addressing, storage or caches or, passing data between different compute jobs that are running on the same machine. Like, I think we're actually going to see, maybe subtracting the more specialized DePin networks, if we're going to see a lot of compute networks and we're going to see a lot of overlap there, we'll see many nodes that are participating as a Filecoin storage provider, as a Fluence compute node, as a table land basin node, and we're going to have the same backing hardware participating multiplicatively, and you're going to have multiple tokens. There might be like a synergistic network design we can do that actually helps create that collaborative fabric between those different networks and nodes, which I think is really exciting. And then that creates an incentive for good interfaces, and the nodes that are participating across those will be incentivized for like, hey, I need a way to easily pass my data back and forth. Otherwise, it's higher costs for me. And so it'll drive down and I think create an incentive gradient for more modularly developed protocols to have simplified interop layers.
Yeah, so basically like multiply and then create the pain, and when people feel the pain, they will solve the problem. Is that right?
Yep, to simplify it down exactly that.
Yeah, that's always my advice when people ask me about like, how do you do org design? And you said like people and technology sort of, it's a Conway's law thing, which goes both directions. That's how you do it. When you're growing a startup and you're growing a team, when do you add management? When everyone on the team is like, oh my God, we need management. And yeah, it sort of resonates with me. Vuk, I think you were going to say something.
Yeah, so maybe a bit of an unpopular opinion, but for us, we always looked at providers as really not caring which part of the community they were from. And that was assuming that we'll get to a world where we have like thousands of networks. They will really not feel being part of each of these communities. The only thing they care is just being greedy and earning as much as they can. And ultimately, our assumption was, let's just make them earn something, and let's make them run as much as they can. And let's try to actually think from the technical perspective, how practical it is for them to run a particular workload and what does that actually include. Because a workload could be like multiple networks that have like dependencies on each other and have like a requirement for like input of data, for example, from Filecoin that requires a job to actually read that data. It requires some computation to be done like on Fluence or anything else. And then it needs to be outputted somewhere, which can be again, a storage network like Filecoin, which requires another job to actually write to Filecoin. And like ultimately, we were just thinking, how do we actually make providers do whatever we want, which is just make them as much as they can in the context of the networks that they are running. So and that's how we kind of got to that interoperability, just by making the assumption that providers are always going to be greedy, give them a daemon that is just going to be greedily selecting whatever makes more sense for you. And yeah, that was kind of the view.
Yeah, when I said on interoperability, because actually we live in the real world, right? And we can see how even if there were attempts of creating interoperable like standards protocol like HTTP, we still have, in Web 2, we still have separate universe. We have web powered by HTTP. We have app stores. We have like big messengers that are like completely isolated universes. And this happens because every like founder or author of something new, basically naturally, I don't know, because of just how people work, because of vanity, because of greed, whatever, creates natural barriers and locks customers in the ecosystem. And I think even in Web3, we see all the same thing. Like people create the new open source, open project network, whatever, Ethereum, Solana, they kind of open. But at the same time, that as Vuk said, they are like there are walls between them, and there's lack of interoperability between them. It's different people, they do not talk to each other, they do not have like a interoperability protocols. And then even if there is someone creates the protocol, it's kind of to propose it as a standard. Then we have a competition of standards on top of competition of networks, and it's always competition. So like it's always the market gonna be looking the way that in DePin as well, is gonna be multiple networks, you know, one bigger network or several bigger networks, and like a lot of smaller networks. And then there are several standards of how they interact with each other. Some of standards more ubiquitous, some of them less. And that's just like heterogeneous nature of humans, and I think it's just everywhere. And we are trying to kind of get rid of it, but it never happens. Like it didn't happen in Web3. I think it didn't happen. It's not going to happen in DePin. So we just need to understand this assumption when we think of universality, interoperability, and standards.
Certainly, yeah. I mean, even before Web3, like I used to do a lot of stuff in the Ruby open source community, and I co-created the package manager for Ruby called Ruby Gems, which led to NPM and pip and all these other things. And as soon as we released it, another project came out explicitly in every way opposed to us, and there was nothing to be gained except for being jerks. I hope you're listening now online. They were jerks. But it's just crazy. And you're right, like humans, this is one of those coordination failures that we all love to talk about in Web3, right? I do wonder, and maybe none of you have an answer to this, but can crypto solve this even? Is there a mechanism that you can build? Are there incentives you can build to create interoperability?
I would argue it just amplifies it. And if you think about, so by the way, this is not just in tech. So if you think about why the US has so many cars and why there are no trains, just because initially that's hard and enough people had skin in the game, and it's so hard to get out of that. And like crypto just amplifies that, because Ethereum is not great, but everyone has skin in the game there. We are not going to change Ethereum. Similarly for JavaScript, JavaScript was really bad. Like JavaScript is wasting so much energy, but JavaScript is there now. It's kind of okay. We kind of forced a bunch of people to learn how to deal with it, and it works. And I think in crypto, what we are doing is we are just supercharging economies, and it's just going to be worse.
I don't know. I think about silos in crypto as, there's one thing to be interoperable. There's another thing to be compatible. We're in the compatible era right now, where we're just stringing things together. Like cross-chain bridges is a great example of this, right? Like you have a cross-chain bridge asset from layer 0 versus wormhole on the same blockchain. Those are two separate types of tokens completely. Those are not interoperable because they come from different standards, and no one's agreed on the final standard for what this cross-chain bridge token should look like, right? So I think the IoT space, the Internet of Things space, is also one that's extremely siloed, right? You have all these devices that are running different operating systems that don't talk to each other. And I think the way to bring all of that, all those devices and data into DePin is you build these translation layers. Maybe, you know, many different forms of OSs are dumping data into one, you know, compute layer or a data pool, and then split all those proofs into different blockchains. It's kind of what we deal with a lot at IoTeX with WebStream. We try to make this neutral layer as compatible with different standards in the real world as possible. And then it's kind of a many to one to many relationship. Then you have to make the proofs compatible with all the other blockchains that want those proofs, right? So yeah, it's the silo problem is not something that's really easy to solve. You have to pretty much get everyone to use the same common denominator, but we're probably going to see a lot more compatibility solutions in the form of cross-chain bridges for tokens. Probably going to be a lot of cross-chain bridges for data or other types of DePin-focused things, right?
But I can argue that bridges between Ethereum and Solana, for example, gonna always be crap compared to bridges between EVM networks. So like roll up in Ethereum, because it's the same virtual machine, it's the same infrastructure. It's gonna be much more seamless versus like completely different chain. So like, yeah, we're trying to do compatibility, but some of this compatibility always gonna be bad.
Yeah, and I think that's the difference between like, you know, cathedral top-down standards versus bottoms-up de facto standards. The bottoms-up de facto standards take longer because you need to recognize as a community, like, you know, this is about as good as we're going to get, and like the momentum is here, and so we're going to make all of these chains. Like I think Solana's working on an EVM compatible layer so that they can interop between that layer and the rest of everything more seamlessly, because that's where the de facto standard has moved now. Like FVM is also EVM compatible. Like all networks are seeing that kind of like central interop layer, but it takes longer for that to emerge, standardize, kind of solidify as like, great, you know, we're going to use IPFS for our content addressing. We're going to use libp2p for our peer-to-peer networking layer. We're going to use EVM for our like VM compute layer. And that, you know, you might do other things. You might augment it in addition to that, but that's the common interop layer. And I think, you know, that takes longer. And so you're going to see more experimentation maybe in the DePin space of things going 12 different directions and then figuring out what works, what is actually a commonality. And then those things have gravity over time because you can do more when you can interoperate better. And so we'll see a lot of experimentation, and it'll be a little bit more organic in terms of, all right, you know, the marketplace will tell you what actually gets traction, and then people will start adopting what will give them more momentum and where the users come from. And so I think we'll see it happen over time, but how we do it in the Web3 space is going to be chaotic, and it's going to take longer than a perfectly designed Apple operating system from Steve Jobs.
Yeah, thank you for saying cathedral, because you allowed me to go ahead and say, read the cathedral and the bazaar. And so that's Eric S. Raymond's essay from the 90s that really catalyzed a bunch of open source stuff. And then there's another one called Worse is Better by Dick Gabriel, who was, I think, the first person to write a design patterns book in software, which also encompasses this sort of idea that, like, in this case, it was two different schools of Lisp development, Scheme versus Common Lisp. And Common Lisp was the really cathedral mode sort of thing, and Scheme was the bottoms-up thing. In that case, neither one, because people don't really use Lisp, but they do. That's not true. Closure. Ruby Gems won, by the way, and it was bazaar mode. So I'm with you. I wasn't really complaining about that. Let's go back. I made us talk about all this nerdy OS type stuff and standards because that's what I like to talk about. But we should go back to DePin a little bit, and I want to ask you all. Like I wish I was building directly in the space, but apparently I'm a money manager now, so I don't even know what that means. But if I were, I would find myself frustrated, I'm sure, because I'm always frustrated when I'm trying to build something. There's like an ambition I have, and I don't know how to, or I know what I need to complete it, but there's like something I haven't figured out, or something that isn't possible. What is that thing right now for DePin, for one or more of you? And it doesn't have to be something you're working on. It could even be something like, I wish I had the time to work on it, but I don't because I'm working on this other thing.
Yeah, I think a big trap in DePin for everyone, Golem and a bunch of other networks trying to build stuff, is everyone thought they would do a generalized network. It's impossible. Like, you can't. And like, so much money and engineering time was actually spent trying to do a generalized network. Our view from the start was, we don't want to build a generalized network. That's kind of a religious view that we have. the second one is we don't want to build a scheduler. We just want to build the least possible amount of things that we can build. And even that is like the complexity is through the roof. And we are basically just allowing people to match-make jobs and connecting economies. So yeah, we would definitely love to build a generalized network. Our view is that the more networks we support, those are basically dots on the line. And the line is a generalized network, but it's basically impossible to get there. Like we are just adding dots, and we are hoping that at some point we'll just populate that entire line. But yeah.
I think like for me, the exciting part about DePin right now is like the framework that a lot of people use to describe these ecosystems is like supply and demand, right? I think the supply side is getting so much easier because of the availability of hardware. There's a lot of new third-party devices that support multiple networks. So launching a DePin from that perspective is easier than ever. And you have a lot of people, it's easy to build a supply side in a way because you give incentives to people to purchase a device, and that device is going to print the amount of money you paid for the device in 1 to 2 to 3 months if you are trying to bootstrap as quickly as possible, right? Probably better to start at a more sustainable emissions rate. But supply side is, there's a lot of great examples of projects that have built effective supply sides, right? But that's maybe not even half of the story. The other side is the demand side, right? Where and the problem with DePin, demand side, is oftentimes it's like a delayed gratification type of situation where if you're trying to build a data network, like let's take Demo for example, right? They're trying to compile a lot of the data from different vehicles, potentially make it available on a data marketplace. The value of data is really due to the density of the data and the duration of the data, right? So you can incentivize people today start their data journey, but 2 years from now, when you have a time series data set that's actually valuable and dense, that's when things really get interesting. But how do you maintain people's attention for those 2 years? That's why there's so many incentives delivered in the early days, right? I think the way that DePins are going to grow is no different than I think a lot of the sharing economy applications of the real world. Like take Uber, for example. In the beginning, they subsidized drivers and riders extremely heavily, right? DePin is a little different because they give equity to those early adopters. Uber gave cash, but now they're crowding out their market share and fitting more demand for their network over time. I think DePin projects often start the same way. They give a lot of incentives out to early adopters in the beginning, very similar to those subsidies from Uber, and over time, you have to fit real demand and real revenue into the equation. So I'm excited to see so many new DePin projects launching. Not all of them are going to have the chops to really figure out the demand side because that's real business development, real data science, real value extraction, demand for users, services, or data. But it's going to be interesting.
Yeah, from the Filecoin side, I think Juan talked about it earlier during your guys' chat, but definitely it's a trap to fall into the building up supply without building up demand. I think we built up tens of exabytes of supply, and we're at now 2 exabytes of demand, which is a lot, but still not very much compared to the supply side of the Filecoin network. And that is where, that's where the value's at. You have to have both sides of that marketplace being built together. I look at all the DePins getting started today, and I'm very jealous of the building blocks that do now exist to, make that get started more efficiently. Building an L1 blockchain from scratch, really fucking hard. Whereas there's now stuff like IPC that can help networks get started faster as booting up, having stuff like, EVM compatible FVM built in. You can add your own WASM actors.
Can you define that really quickly?
Oh, IPC, Interplanetary Consensus. It's the framework that Fluence is building upon. It's kind of a layer 2 framework that's highly scalable, both horizontally and vertically. That has come from the kind of Protocol Labs ecosystem. It's building on top of Filecoin. And so I think those sorts of building blocks, I would love to someday rebase Filecoin on top of that so that we can have all of the benefits of that horizontal scalability as well. Stuff now having things like FVM, EVM compatible built in means that you can put so much more of your core logic in kind of smart contract style upgradable actors we were doing all of this stuff like embedded in, you have to do like these high overhead network upgrades in order to make incremental improvements to the logic of your network. Now, you can do all of that, directly in user land smart contracts. You can upgrade and iterate on your capabilities a lot faster. Totally agree with what Vuk was saying about orchestration. Orchestration is hard, and I would love, and I still think this is probably a pain point, is things like well-running decentralized orchestrators, and things that do things like job scheduling or kind of like routing of jobs to nodes. I think some better defaults. There is a decentralized compute network exemplar in Bacalhau that I think has a very, very, very basic version of like job bidding, where you can have nodes bid for the jobs that they want to do, and then it'll assign it based on like, great, you bid more for this. But then you have to have the logic of like, okay, well, when am I gonna bid on a job and how much? And like, there's layers to that I think is still pretty complicated if you're gonna build up an efficient network that competes with a more centralized top-down set of logic. But I don't know, I think there's really cool building blocks that do exist, and I think everyone who's building DePin networks today has a lot more that they can reuse than, say, 3 years ago.
Yeah, on that, the centralized scheduler is not a scheduler. It's basically just an incentive and a market for computing. And over time, we are just getting to that by just incentivizing people to do whatever they want on a particular resource.
I wanted to get back to a question about what's possible and what's impossible. So I think in DePin space right now, from user perspective, almost everything is impossible. Or, because like try using all these networks, including ours, like there's a lot of problems with it, right? But in the end, what the user wants? They want price, reliability, security, performance, right? It's very simple. And we are doing all this great job about organizing global resources and scheduling and like orchestrating jobs. But then if I'm using it and I realized, oh, it's actually not secure, it's just some random machine in some, some person basement running my job, and I don't even know whether it executed correctly or not, and then the electricity shuts down, so my job is not finished and I have no guarantees, I'm probably gonna use cloud instead of it. Because cloud at least give me like some nines they promised me, and there is a guy who I can call and say, why your stuff doesn't work, can you give me credits on my account, and they do it. So like from user perspective, there's a lot of such simple things that they want, which are not being really provided by majority of networks right now, unfortunately. And that's a matter of time. I'm sure we'll get there, because that's the better way to build infrastructure with these DePin networks. But realistically, we are not yet there.
Yeah, I think one of the biggest issues is that since we really try to innovate, we always look at what's next and what's the next thing that is possible, and we never settle for actually making it work for the worst possible thing. So in the context of Filecoin, I think at least for me, while I was at PL, we should have focused on just making our HAL great, and just get people to use it instead of Glacier. Let's disrupt that market. Then let's get to the semi-hot layer, like Coldline, whatever. We make maybe unsealing faster, or we have some other tricks, and then we can slowly go up the stack. Instead, we focused a lot on what was next. We're focusing on things that are today impossible. For example, I would argue that a hot layer that has formal verifiability today is not possible. It might be possible in a year, or it might be possible with some cryptography that we still don't know how to glue together to actually get a network, but it needs to be a completely separate thing that has a completely separate, not economy, I don't want to say that, but it needs to be a different workload. It cannot be the typical Filecoin workload. And yeah, when we were bootstrapping our network, we focused on just making Filecoin as good as possible. And at the end, we ended up not using any implementation. We just focused on the cryptography that was actually part of the consensus of Filecoin, and we have no node or whatsoever just to run Filecoin. And we had to rethink all the personas participating in this space, because Filecoin had to abstract a lot of complexity that was needed just to get that storage on. And Filecoin was always thinking from the perspective of how do we do storage, And to get to that storage, we had to do a bunch of compute, but we always thought that was a storage provider. No, it was a storage provider that 90% of the time was playing the role of a compute provider, often was playing the role of a token holder, and he was like doing everything. And we were assuming that we would get like the same upside that we saw from Bitcoin, where like you have a very simple thing, you run like a SHA-256 on whatever. And we didn't, because like it was so hard to actually be that storage provider. And yeah, like ultimately making it simple, making it just focus on one thing and slowly just capture value from that.
Yeah, I think a lesson learned there, and we've called that the fat SP versus thin SP thesis, and we've sorry SPs to describe it that way. But like when Filecoin first got started, storage providers were the backbone of the network. They were doing all of the work. They were playing all of the different roles, and now over time, now that we have Filecoin Virtual Machine, we now have the ability for folks to provide collateral and do kind of like leasing and staking, that unlocks an unbundling of the different roles that you can play inside of a network. And so I think it's a good lesson learned for other DePin networks to think about, like, actually, can you unbundle and put different responsibilities on different node types and different participants instead of trying to bundle them all together into a single provider type, so that you can end up, we now have, the collateral providers, we have the compute providers that do things, what we call sealing as a service. You have the storage providers that are doing just data hosting and like very small, lightweight proofs over that data. We have folks that are like doing data onboarding and aggregation separately. So we're now 3.5 years since mainnet, almost 3.5 years since mainnet for Filecoin. We've evolved over time to have more specialized roles and to not put all of those requirements and responsibilities onto one specific node type.
Yeah, I would say, like, in retrospect, everything's obvious, right? Which is the funny part, because like IoTeX has been around for a while, since like 2018. And I would just reading. We took a trip down memory lane. We have like a bunch of team members in town this week, and it's our little team summit. We're taking down a trip down memory lane, reading our original white paper from 2017. I don't think the vision has changed, but like the approach to realizing that vision at like a technical component level has changed a lot, right? We have ZK today that didn't exist in 2018. We were talking about like ring signatures and bulletproofs and all these things that just didn't pan out for like the enabling privacy and scalability part. We were talking about sub-chain structures and plasma chain structures. Now we've gone to layer 2, right? So I think as incumbents in the space, like, you have a desire to get somewhere, you need a lot of iteration, but sometimes someone solves one layer and it becomes the de facto standard, I guess. I don't think anyone's going to try to compete to say like ZK is not going to be a really important part of layer 2 rollups, but a lot of people are experimenting at the detailed level, right? So I'm curious to know, we're about to announce IoTeX 2.0, which is like a redefinition of our future vision, but once IoTeX 3.0 comes out, we're probably going to be laughing at ourselves, being like, man, that was stupid, right? So.
Hopefully. Because if you aren't, then you didn't learn anything, right? That's one constant thing. The other one, though, I would say, like, there is something that we can go back in history and see, and that is this unbundling fact. The question is just how do you see it in the moment? It almost requires mindfulness and like a very explicit thing. But like in the 70s, Unix did this Unix philosophy of do one thing well and then just have really good pipelines between the tools, and that's what we all end up refactoring to eventually. Except maybe Fluence network. We met last night, and I was learning about how how the vision was, and I haven't had a chance to like read the docs, so I'm probably going to say something stupid. But my understanding is what you're talking about is like really clear, just like maybe even not quite pure functions, but that sort of a concept of just clear inputs and outputs with the ability to know that you're running exactly the same function every time, which leads to the same sort of composition on the web that you could get in Unix, but better, because you're not actually doing standard O pipes, right? So I'm curious, like, am I right about that? And how do you think about composability in DePin overall? We started off talking about how the protocols can collaborate. And I would say even within the EVM, composability is terrible. It should be good, but it's terrible because the projects are doing these big, nasty smart contracts that have too many things in them. and they do that partially because you have to for gas costs and whatever. But, so maybe Evgeny, if you could talk a bit, maybe more specifically about what you do and how you enable composability at this execution layer, but then generally for all of you, how do you think about composability across DePin networks now and in the future?
Yeah, I think, so what was said here, like for example, about unbundling Filecoin to like different tasks and different kind of roles, more specific roles on the network are responsible for different tasks. That's the example of actually this Web3, the whole Web3 unbundling narrative, right? So even if we are creating the network and trying to silo it from other networks, we still can see that there is a benefits if we unbundle the network itself also to like a more granular level. I mean, in terms of Fluence and our thinking about these functions and composing stuff, so basically, we are trying to create the right distributed computing system because whenever you have a computing task, usually you have you have this like either huge tasks that you need to parallelize, or you have like a huge load of users that open the same website page, for example. So this massive amounts of requests per second needs to be handled by some infrastructure. So, and this is the reason why you need distributed computing at all. Distributed computing is a way to scale the computation, right? It's either parallelize or serve like a huge load. So you, because the hardware, the unit of hardware is limited in terms of how much compute it can do. So, and you start, like you basically, when you have these huge loads, you inventing distributed systems in a variety of different setups. You may have, you have databases as a distributed system, you have data pipelines as a kind of combination of different execution steps happening on different machines, on networks or something. So, but it's all about, some workflows of jobs or function calls, basically, like sequentially or like parallelize. You can have loops of these function calls. Like you can express the workflow as some kind of algorithm on top of jobs or function calls. And these jobs can happen in on a different servers, in a different networks, in a different protocols. So, but they together like a kind of executing some business use case and business scenario. So our functions, our cloudless functions is basically this, is a way to express this composition of different jobs. And job can be anything, like it can be like call to database, it could be like computational job, it could be like event happening from somewhere and triggering this. And yeah, so like we see what we do as actually like composition layer for many of other projects, protocols, workloads. Even Web 2, we can write data in S3. We can be triggered by HTTP event. It doesn't matter, like, because we want to. If we want to onboard more users, we need to bridge Web 3 with Web 2 anyway. If we want to onboard a lot of data to Filecoin, we need to allow easy migration. And easy migration means what? It means probably that this data already lives in S3 or getting sent to centralized cloud initially and then somehow like ends up into Filecoin. Yeah, so our view of this is a framework of building distributed systems and building connections between these Web3 networks, universes, and both on the physical infrastructure level and on the protocols level and on the networks level. Yeah, I don't know if it answers your questions.
Wonderful, thank you. Any other comments before we wrap up?
I think if you think about all the DePin networks out there, it's always going to have a particular executable, or you can look at that as a function. And I think where we are going to get is we are going to have a la Docker moment where something is going to allow you to define these different jobs that need to be executed for executing a particular use case. I hope that it's not going to be us having to do that, but we need that something. Because right now, if you are a developer that needs to encode a video and then do some particular computation on top before you store that somewhere, it's not like you're going to be defining like and looking at like all the docs of these different networks. The only thing you care is really being able to compose these jobs. And we'll need something a la Docker, and hopefully it's going to be an open effort from all the different communities.
Okay, well, that brings us to the end of the panel. Thank you very much, brilliant panelists. I have learned a lot, and I know everyone else has too. So thanks so much.
Thank you.